Let's find the sum of the series. So here's a couple of hints. The first word I see is the word series. Series is going to have a formula with Sn. The question then is the sum going to be arithmetic or geometric? Well, if you have a base and an exponent that is a number, your answer is going to be geometric. Okay? Now, there are two formulas for the geometric finite series. And here are my two formulas. And you could use either one, but I crossed off this one because I need the first and the last numbers in the list. But this one, you only need to figure out the first number in the list. Remember, they didn't give you a list of numbers, so everyone say, make a list.
Make a list.
Making a list of numbers is a good strategy. And I don't really want to figure out the 6 numbers. Does that make sense in the list? And this is how I describe it to the other class. Think of it if you watched football yesterday. Raise your hand if you watched football yesterday. Okay. It's kind of like, these are like the quarters. First, second, third, fourth quarter. But you don't know what the specific score was. And that's what we're figuring out. So this is kind of like the number in the list. And we have to figure these out because we don't have those. Let me do the first one. Everyone say summation. This is the summation symbol, and you start at 1. Whatever's in the bottom, you start there, and we end at 6. So they actually want us to find the sum, or add up all 6 of these numbers. To get the first number in the list, I'm going to start with 1, and I put a 1 in for n. 1 minus 4 is -3. -2 to the -3 power, you're going to take all of that and move that to the bottom of the fraction, and you get 1 over 2 to the 3rd power. 2 to the 3rd power is 2 times 2 times 2, which is 8. The first number in my list is 1/8. Now, I don't really want to figure out all 5 other numbers. I can just use our formula. So our G1 value is 1/8. Every n value there is 6. And I got 6, not from here, pay attention, because that says n equals 1. That's my starting point. If you figure out, if you count from 1 to 6, there are 6 numbers. So every n value is 6. My r value is the ratio, which is the base of the exponent. The number there, the big number. So I'm putting a 2 there. So I get 1/8 times 2 to the 6 minus 1 all over 2 minus 1. And then I'm going to do order of operations. So I'm going to do what's inside the parentheses first. So 2 to the 6th power is 64. And 64 minus 1 is 63. 63 times 1/8 is 64 minus 1, which is 63, and then 8 times 1 is 8, so that's 63 over 8, and if you put that in your calculator, you'll get S6 to be 7.875. Alright, for both these questions, for number 4, it says find the common difference of the sequence. Notice as you read from left to right, the number's getting bigger. So common difference means either addition or subtraction. It's going to be a positive as your answer because the numbers keep getting bigger. Then you can just take this number, 28.39, and subtract it from the first one because that means common difference. So 28.39 minus 19.82. And you get 8.57, and then you can essentially add 8.57 to each of those numbers. And you get that number, and then add 8.57 again, and then you get this number. Okay? That's question number 4. Number 5. If the first number in the list is 1,000, and d is equal to -4, find a of 52. A couple of warnings here. If you go onto the internet, they actually confuse you by telling you the number on the list is all A's. Because A stands for what class? For us, in our class, in our textbook, A stands for arithmetic, but sometimes on Khan Academy, they'll even put the letter A for geometric. But I think this book does a really good job of clarifying. Now you're like, I'm not sure if it's arithmetic or geometric. D stands for what? A common difference is arithmetic, right? Now, I'm not going to use an S or SN because this does not say find the sum. This is saying just find one specific number, the 52nd number. So if you look at your formula sheet, put your finger on the formula that you would use for this one. I would use this one to find one particular number. I would use the explicit because I already have the first term, and I can just do all my substitutions. My AN value is the last one, which we're trying to find is the 52nd number. The A1 value is 1000. The D value is -4. My N value, if you don't know that, you just put AN above what you're finding, and you get 52 here, -1. And then you just go through and simplify. 1000. This becomes -4. Remember, if you see a plus or minus, just have the negative sign. 52 minus 1 is 51. What happened? -4 times 51 gives me -204. So if I subtract those two values, I get 796. So the 52nd number in that list will be 796. In question number 6, it says, what is the sum? So your formulas, you should have S for sum of a series. That's another hint or another word. This one gives you a summation, and it tells you to start at 1 and go to the 61st number. And it gives you this equation here. Now the question might be, which is it, arithmetic, geometric, or neither? Well, we did a previous problem where your base is a big number. Okay, that's going to be a geometric, or later on in the next chapter we'll call that exponential. So it's not geometric, the answer is arithmetic. It's arithmetic because you can see here that your common difference is actually going to be 0.2. So, to find the sum of this arithmetic series, I'm going to have to find the first and the last term. Well, the first number in the list, I don't have a list of numbers, so I'm going to have to use summation notation. Start at 1, and I'm going to put in for n. And then if I multiply those two, I get 0.2 plus 2.6, and I add those together, and I get 2.8. The first number in the list is 2.8. So I get 2.8 there. Then I need to find the last number in the list, and I end at 61. So 61 is equal to, here I'm using my arithmetic explicit formula. So in this problem I'm actually using two formulas. How many formulas, class? That's okay to use two formulas. And then I'll just punch that into my calculator. 0.2 times 61. I get 12.2 plus 2.6, and that'll equal 14.8. So the 61st term in my list will be 14.8. So I get S61 equals 61 plus 2.8 plus 14.8, all divided by 2. And then I'm going to use order of operations here. I'm going to add these two numbers first. plus 14.8, 16.8, and I'm going to multiply that by 61, and then divide my answer by 2. And the 61st number on the list is 512.4, which I assume is letter choice. What letter is that? Is it C? It wasn't C? No?
No, there was no answer. That's not even. That's not on the list.
That's not one of our options. Not good. Let's take a look.
But it was supposed to be C, right?
536.8. Alright, so let's double check. I think it's 62. Let's check. 2.8 plus 14.8 gives me 17.6. 17.6 times 62 divided by 2. No. Anyone see my mistake?
2.8 plus 14.8 is 17.6.
I added wrong here?
Yeah, I got 27.
I got 72.6. And then I multiplied it by 61 and I got 1,073.6.
17.6.
I divided it by 2 and I got 586.8.
61 divided by 2. So this is a great teaching opportunity. This, everyone say calculator ready equation. That's going to give you a 3 out of 4, and then wrong answer, but you have calculator ready equation. At least can give you majority of the points. Push back at us. Have a good day. Question number 1. Find the 6th term of the sequence. So here, they're telling me the 6th term is n equals 6. You can't see that, so let's switch that again. So I circled the 6th term here, and I put n equals 6. We kind of say the nth term is the 6th term. That means n is equal to 6. So now I can just substitute it in. Every n value I'm putting in 6. And then I can just simplify. 6 squared is 6 times 6. Common mistake is 6 times 2. And that would be 36 minus 6, which is 30. Raise your hand if you got 30 for the first answer. Alright, question number 2 says, does the sequence 8, 6, 4, 2 converge or diverge? This will be tomorrow's lesson. But you can go ahead and look at your maps there on 8.4. Look at 8.4. I'm opening up my map. And something you should recognize is what's happening to the numbers. Okay, they are decreasing, but what's happening from each of these? Okay, someone said subtract by 2. What's happening here is that your ratio converge is if it's less than 1, and this one is if it's greater than 1. So this value here is you're going down by 2. Your R value is 2, and so I know it's going down. So their answers diverge, and we'll go over that tomorrow. So don't worry if you didn't know it. Question number 3. Find the sum of the series summation n equals 1, n 6. So this is your starting point, and this is your end. You're basically saying that there are 6 numbers in the list. And remember, the n or the I here does not represent the numbers in the list. This is kind of like the picture number, right? If you're watching football yesterday, it's kind of like first quarter, second quarter, third quarter, fourth quarter, but that doesn't tell you actually what the score was during those times. We have to figure that out. Well, recognize here that a geometric. Alright, for question number 7, it says find S22 of the series 0, 1.3, 2.6, keeps going on. So a couple of things is, series just means the plus sign, but I don't know how to go from there to there. And then you can just take your calculator and subtract. So 1.3 minus 0 is 1.3. And then 2.6 minus 1.3. So from here to here, I'm adding 1.3. What do you think the next number is going to be? Well, if I add 1.3 to that, I get 3.9. So my common difference here is 1.3. S, I don't want to keep doing this because this is my first term. So because I have a common difference, this is arithmetic. This is the first number on the list, second, third. I don't really want to get all the way down to the 22nd. I can just use some formulas. So to find the 22nd number in an arithmetic series, I can use the explicit formula. Explicit formula is to find one particular number. I'm not going to use the recursive because this is saying find if I had the 21st number, then I can just add the difference. Well, this one's just saying if I write down that formula, an. So let's write that arithmetic explicit equals a1 plus d times n minus 1. And in this problem, my an value is the 22nd value. My first number on the list is 0. My difference is the common difference, 1.3. And my n value is here, which is 22 minus 1. So I get 0, we don't have to write that, 1.3 times 21. So 1.3 times 21. It gives me the 22nd value in the list is 27.3. Now that's not my end result. My end result is to find the series or the sum. So another word for series is sum. I'm going to add up all of these numbers up to the 26th number, which I just found to be 27.3. Well, to do that, I'm going to have to use a different formula. And the formula for that, look here, will be a finite arithmetic series, and this is my sum, right? Because it's arithmetic. Remember now, you're not going to use this side because this is geometric. You have a common ratio. This one has a common difference. So, finite arithmetic series formula is Sn equals n times a1 plus an over 2. So I need to find the sum of the 22 numbers. My n value is 22, so 22 is my n value. A1 value is 0. Okay, my last number here is A22. My 22nd number on the list is 27.3. And we're going to divide that by 2. So I have S22 equals 22 times 0 plus 27.3 is 27.3. I'm going to multiply these two numbers and then divide by 2. So 22 times 27.3 is 6,006 divided by 2, divided by 22, and I get 3,003. So if I added all the numbers in my list, given this sequence of numbers, all the way up to the 22nd number, notice I skipped those numbers, it's 3003. So first use the arithmetic explicit formula to find the 22nd number. Then from the 22nd number, now I have the first and last numbers, and then I can use the finite arithmetic series formula, which is here, and this is our sum. I made a mistake. So here, let's do it again. 22 times 27.3 gives us 600.6, and if I divide that by 2, I get 300.3, which is our answer. Not 3,000. So 300.3 is our sum of the 22 numbers added up.